Hi, everyone, and welcome. Today, we're going to take a deep breath and look at the very thing that makes that breath possible, the Earth's atmosphere. It's this amazing, super complex system of gases wrapped all around our planet, and let's be honest, it's the only reason any of us are here. So, let's dive in and take a closer look at this incredible, invisible shield. And just to put this into perspective, think about this. If the Earth were the size of an apple, our whole atmosphere would be thinner than the skin on that apple. Seriously, that tiny, fragile layer is all that stands between us and the cold, unforgiving vacuum of space. It's a powerful thought, isn't it? So, we're going to explore this invisible shield, this thin blue line that makes everything we know and love possible. And trust me, it does way more than you might think. I mean, the atmosphere is a master multitasker. It's doing several critical jobs all at once. First, the obvious one. It's got the oxygen we need to breathe. But it also acts like a giant planetary sunscreen, blocking the most dangerous ultraviolet radiation from the sun. It works like a blanket, trapping heat so our global temperature doesn't swing to deadly extremes. And it's even our cosmic bodyguard, burning up most meteors before they can ever hit the ground. A true jack of all trades. Okay, so that's what it does. But what is it, really? Like, what are we pulling into our lungs with every single breath? Let's check out the recipe for air. So when you look at the main ingredients, there's a bit of a surprise. You'd think it's mostly oxygen, right? But nope. Look at that. A whopping 78% is actually nitrogen. Oxygen, the gas we absolutely can't live without, only makes up about 21%. And that leaves just 1% for everything else, like argon and tiny amounts of other gases like carbon dioxide. So what's really key here is the relationship between these two titans of the air, nitrogen and oxygen. Nitrogen is kind of the silent majority partner. It's vital for life, yeah, it helps build proteins, but its main job in the air is just to dilute the oxygen. Why? Because pure oxygen is incredibly reactive. Without nitrogen to basically calm it down, every little spark could set off an uncontrollable fire. Then you've got oxygen, which of course is what our cells use for energy, and it's what makes fire possible. They create this perfect, delicate balance. All right, now for the fun part. We're going to go on a journey. We're going to climb up through the atmosphere, layer by layer, starting right here on the ground and going all the way to the very edge of space. Let's see what we find. So, our first stop is the one we all know best, the troposphere. It starts right here at sea level and goes up about 12 kilometers, or around 7.5 miles. This is our home turf. This layer is where pretty much all the action happens. It's the densest part by far, holding about 80% of the entire atmosphere's mass. Every cloud you've ever seen, every thunderstorm, every gust of wind, it's all happening right here in the troposphere. And if you've ever hiked up a tall mountain, you know this rule. The higher you go, the colder it gets. Okay, climbing up above all that weather, our next stop is the stratosphere. This one goes from about 12 up to 50 kilometers. And this layer has a very, very important job. See that dotted line? That's the ozone layer. The ozone layer is our planet's non-negotiable shield against the sun's worst UV radiation. It just soaks that energy right up. And because it's absorbing all that energy, something really weird happens to the temperature here. Unlike the troposphere, in the stratosphere, it actually gets warmer the higher you go. A total temperature flip. Let's keep climbing. We're now reaching our third stop, the mesosphere, which basically means the middle sphere. It stretches from 50 up to about 80 kilometers, and this is where we get our celestial light shows. The mesosphere is crazy cold. It drops down to about minus 90 degrees Celsius. That makes it the coldest spot in our entire atmosphere. And it's here that most of those little bits of space rock burn up from friction with the air. So next time you see a shooting star streak across the sky, you'll know exactly what's happening. You're watching a meteor vaporize in the mesosphere. Okay, onward and upward. We're now climbing from 80 all the way up to 700 kilometers to enter the huge thermosphere. The air here is unbelievably thin, but it's also home to some of the most beautiful sights you can imagine, like the aurora. Now get this. Temperatures up here in the thermosphere can hit 1,500 degrees Celsius. But because the air molecules are so incredibly far apart, it would still feel freezing cold to you. It's a weird physics thing. This is also where the International Space Station orbits the Earth, and it's where charged particles from the sun smash into gas molecules to create those breathtaking northern and southern lights. And here we are, our final destination, the exosphere. This is the absolute outermost layer. It starts around 700 kilometers and just, well, it gradually and almost invisibly fades into the blackness of space. This is the true final frontier. The air molecules are so spread out they can travel for hundreds of kilometers without bumping into each other. There's no hard boundary, just a slow fade to nothing. This is the realm of many of our weather and communication satellites, silently making their way around the planet at the very edge of Earth's embrace. So we've seen what the atmosphere is made of and explored its incredible layers. But how did it even get this way? I mean, it wasn't always this nice, friendly mix of nitrogen and oxygen. Its story is billions of years in the making. Well, Earth's very first atmosphere, made of light stuff like hydrogen and helium, was basically blown away by solar winds. Then, about 4 billion years ago, volcanoes went nuts and created a second atmosphere, one that was super thick with carbon dioxide and water vapor. Totally unbreathable. The great turning point, the game changer, came about 2.7 billion years ago, when the first tiny little organisms started doing photosynthesis and pumping out oxygen as a waste product. And over billions of years, these tiny life forms completely re-engineered our planet, creating the very air that complex life, like us, would one day need to survive. The most incredible part? Life didn't just adapt to the atmosphere, life created it. And that brings us to today. When you understand this incredibly long history and this delicate, layered structure, it really makes you realize just how precious and fragile this atmospheric blanket of ours truly is. This quote just nails it, doesn't it? This thin layer of gas isn't just some background feature, it's the fundamental operating system for all life on Earth. For billions of years, geologic forces and then the earliest forms of life shaped our atmosphere, building a world that could support us. And now, for the first time in Earth's history, one single species, us, humanity, is the main force changing it. Which really leaves us all with a pretty profound question. What kind of atmosphere will we choose to create for the generations that come next?